Hello everyone. Welcome back to another session on data science by Gamma's Academy. And today we will discuss how should we work on DS project or data science project end to end, or the steps we need to take when we start any data science projects. I have tried to capture many basic steps which are important, but for different problems they could be different. Okay? Also, the steps and decisions are totally based on individuals' thinking and can be debatable. So here I am not going to prove whether my model is good or bad, but I am going to show you the steps and the results could be debatable. Also, I am trying to demonstrate a sample project and there are huge scope of improvements to the results. I have not given much focus on the feature selection in this project or in this tutorial and will talk about the feature selection process in separate video to keep the video simple over here. So let's start. So here today we have taken the data set from the Kaggle.com and the data set is about telco customer churn. The sample data I have pasted over here, you can see it is in CSV format and it has around 20 features about the customer and the result is whether the customer is remaining to the network or they churn or they left to the network, left from the network. Okay, so here we can see we have some customer ID, gender, senior citizen, whether yes, true or false, some partner, dependency, tenure, and so on. Okay, and our output is churn, whether yes or no, right? So we are going to build a classification model for this. So let's start. And I'm using Jupyter Notebook and Python for the project. So let's start. So the first thing we will do, we will import the libraries, required libraries, which I'm doing over here. Then I'm reading the data set. I'm reading the CSV file and storing it into the dataset variable. Okay. Then the first step should be we should check the shape of our data set. So we have taking dataset.shape. So here we can see we have 7,043 rows and 21 columns in the data set. Okay. Let's move ahead and let's dig into some more details of the data set. So I am using some commands to print number of rows, number of columns, the feature names, missing values numbers, and unique values. Okay. So here we have, as we discussed earlier, we can go by this or we can take this method and we will find number of rows is equal to 7,043 in my data set, 21 total columns. The features are customer ID, gender, senior citizen, partner, dependents, and the last one is churn. Okay. Missing values, there are total 11 missing values in my total data set. Okay, and the unique values are like in customer ID we have total 7,043 unique values which we can understand IDs will be unique for every customer. In gender we have two unique values, male or female, senior citizen, true false, and so on. Monthly charges we have different unique values for each entry, so this could be different for everyone. The total charges we have some some 6,530 unique values. Okay. So now we have understood what is the data set all about, what are the parameters are given to me and so on. So let's start thinking about the problem statements and the probable questions which we should be able to answer after the analysis. So what could be this step is very important and we should brainstorm with the experts and the domain experts or the project manager to identify what could be the problem statement. So here I have taken two problem statements as an example. Which customer can leave the network or the reason of why are they leaving we should be able to answer why and which customers are about to leave the network, and then we can check how well is the prediction model and the results are doing for this project. So let's move ahead. Once we define our business problem, we will dig into the data set more. So we'll check the data set info. So here we can see the customer ID. Here we have 7,043 entries. Nothing is null in the data set and it is object type. Gender, we have 7,043, no null values, object type. In total charges, we can see there are 7,030 32 values, it means all 11 missing values are from this column. Okay, and then float type is 64. It is showing non-null because there could be some other is maybe some space or something is entered over there. Now let's see with this method just to verify in which column we have the missing values. So here we can see in customer ID or another columns we do not have any missing values. Only in the total charges column we have 11 cells which are empty. So these 11 cells can be treated in multiple ways. You could drop, you can use to fill this 11 cells by your expertise or with your knowledge. Maybe you can take the mean, median, any calculation you can apply and fill these values, or you can drop if you want the values. Okay. Now let's have a look at the example of data set. So we'll use dataset.head method. Here you can see the customer ID, the gender, senior citizen 0 or 1, partner yes or no, dependent. So this is sample top 5 rows of my data set. Then as we saw, there are 11 missing values in total charges. So we can use, here I am using the total charges equal to tenure into the monthly charges to fill the 11 missing values. But you can deal as per your requirement of your problem. So here I am using NumPy as my library to perform this task. So here I am replacing the missing values with the tenure multiplied by the monthly charges of the respective rows. Okay. Next, what am I doing? In my few of the columns, you could have seen the no phone service or no tele internet services are there. So I'm replacing all these values with no. So in my online security, online backup, and these columns, I have few values which are like no internet services, and I am replacing all of them with no, so that I can have only two categories in this. Okay, so this is again dependent as per the requirement. Then if you can see in tenure column we have several entries. Here you see in tenure we have 73 entries, and it is not a good practice to work with 73 categories until it is required. So what am I doing? I am changing my tenure entries to some other classes like between 0 to 12, 12 to 24 months, 24 to 48 months, and so on. So all those 74 categories will be converted to only 5 categories by applying this. Okay, so I have applied if my tenure is less than 12 months, change it to tenure 0 to 12, tenure 12 to 24, tenure 24 to 48, and so on. Okay, so it will change my data set. Now what am I doing? I am separating churn and non-churn customers. So I'm churn is equal to data set where churn is yes and not churn where churn is no. So I'm just taking it to use maybe for some calculations in future also. So I'm just separating them so that I can have a clear view. No need to worry about. And similarly, I am separating my categorical and numerical columns. So first thing, ID column, which is not required, we can understand. ID column do not have any meaning for us for the model. Target column is my churn column, so I'm separating that. Apart from that, whatever is left, then I'm taking whatever the columns are categorical columns, I'm keeping it in another variable, categorical columns and numerical columns, so that I can use them in later. Now let's have a look of the contribution of the output values. So let's see how many yes and no of churn data in my churn data. So here you can see I have plotted a beautiful pie chart, and here you can see where in churn column we have yes as 1869 entries, that is 26.5% of the data set, and for no we have 5174 entries with no answer, that is 73.5%. It means my data is very much imbalanced. I am much interested to see the yes portion, and yes portion is only 26%. So if my model I build using this model straight up this data set, if I build a model using this data set straight away, the model will be biased because we have more entry for no classes. We have to deal with this. So to deal with imbalanced data set, we can use K cross fold method. We can use the smart undersampling and oversampling, these kind of steps. Okay, and we will discuss the things in details once we go into the data pre-processing videos or the sessions. Now I will do the same thing and we'll see the contribution of the categories or the features to the churn or no churn. Like in gender, you can see if the churn customer 49% are male and 50% are female. No churn customer almost same contribution. Similarly, for the another one, customer attrition versus senior citizen. So churn customer when senior citizens are yes, no, sorry, no, okay, that is zero. And when they are not senior citizen, then my no churn customers are like this. Okay. Then partner distribution and so on, so on, so on. You can draw and you can check the details like this. Okay. Now we have a good understanding of my data set. Now I can proceed with the data pre-processing part. So in data pre-processing, what am I doing? I am again taking the customer ID column. I'm taking the target column separately, categorical columns and numerical columns separately. Then I'm taking the binary columns in which I have two outputs only yes or no or 0 or 1. And then I'm taking the columns with multiple entries like 1, 2, 3 and many more. Okay, like in tenure, we have 5 entries 0 to 12, 12 to 14, 24, something like that. So I'm taking all these columns separately in my multi calls. Okay, just to make my life easier. Then I am label encoding my binary columns. So meaning in short, the meaning here we will discuss in details in the separate video about the label encoding and one-hot encoding, all these things. But here, just to understand, if I have any column like yes or no or something like that, the system will not understand. I need to change them into the numerical values. So for that, we use label encoding or one-hot encoding. So here I am using label encoding for my binary columns where we have only two classes, two categories. So there I am converting them to numerical values, you can understand like this. Then for multi-column values, I'm taking the dummy variables. Again, you can say this is something like changing them in numerical values, the values in numerical values. Okay. Then scaling numerical columns, we have some numerical columns in which we have different scales. In one column, we have tenure like just take an example. In tenure, I have count like 1, 2, 3, 4, something like that. In monthly charges, we have values in between 0 to somewhere around 200, and in total, we have values in thousands. So they are on different scales. So we have to bring them into a standard scale. So here I'm using a standard scaler for that and changing the values and converting the numerical values in a standard scale. Then I'm adding all these things in one data set and again making my data set. Okay. Okay. Now all my values are changes to the numerical values, and we have done the scaling part, and all these things are big topics we'll discuss in details in separate videos, but here you can see what are the steps required for the data pre-processing. Okay. Now next thing, I can go ahead and check the correlation between the features. So here I have drawn the correlation of each feature against each feature. So here you can see the phone service versus multiple lines number to phone service is 1. They are strongly correlated because this column is derived from this column only after using the dummy variable. So this is of no use. No need to check this, but we'll check tenure and versus total charges. So there you can see in tenure and total charges are very much correlated to each other. Okay, so that's how you can see each variable versus each variable or the features, how are they dependent to each other. Okay, so here you can see the partner and internet services DSL are not correlated, the gender and total charges are not correlated. So based on that, you can select your features or you can drop your features as per your requirement. Okay. Now let's look at the variable summary. So here I have drawn a variable summary for my data set. So here you can see like here are the features like monthly charges, and monthly charges we have total 7043 count, mean is 0, standard deviation is 1, minimum is minus 1.5, so on. Okay. Now these are all about the data pre-processing and data cleaning part. Now we'll move ahead, and I have not taken any step to select the features. I am going to take all these features whatever I have created. So my data is ready now with the cloning process. Now what am I going to do? I am going to divide my data set into two parts. That is, one is for training and one is for testing. So using this train data set, I will train my model, and on this test data set, I will perform the testing how well my model is doing. So here we can use multiple methods, but I am taking the random samples from total data set into train and test. Okay. So here I have taken 80% of around 80% of data for my training and 20% of data for testing. Now next thing, from the total data set, training data set, I am taking the y variable, that is churn part, separately, and that is y is equal to train and churn column. Then I am taking the y dot head to check the values of top 5 values of y data set. Similarly, for x variables, I am taking out except the churn column in my x. Okay. Now let's have a look at the shape of x and y. So in x, I have 5708 rows and 33 columns. Why 33 columns? Earlier we had 21 only, because we have added dummy variables. Okay. And in y, we have 5708 rows and 1 column. So just I am showing the y here to make sure. Now we have to deal with the imbalanced data set. With the imbalanced data set, we have the very imbalanced ratio of yes or no in y. So we can use k cross fold method or smart method or oversampling, undersampling as per your requirement. We could try various options, and the which is performing better, we should select that. Okay. So here I am just taking the smart function to deal with the imbalanced data set. So I have applied the smart method. Then I am checking the shape of x and y. You can see the size of my data set has been increased because it has added the same data set again, same rows in my data set again, to make the it balance. So here you can see we have now 8364 rows and 33 columns in x, and in y 8364 rows. Okay. I am counting the contribution of both the classes in y. So here you can see they are equal. Now yes and no are equal. Okay. So similarly, I divided my x and y in my train data set. Similarly, I am taking y test from the test data set and x test from the test data set. Okay. Now I am going to my data set is ready. Now we will go ahead and apply different classification models, because our problem is classification problem. We have to guess whether the customer is going to churn yes or no. Okay. So that is my classification problem, and I am going to apply various classification models of machine learning, and we will cross check which one is performing better. Okay. So here the first model I have taken, the Gaussian naive Bayes. Okay. So here you can see from sklearn naive Bayes, I have imported Gaussian naive Bayes. Then I have taken the method of Gaussian naive Bayes, and I am fitting it to my data set x and y. Then I am printing the accuracy of my data set on training set and then on testing set. Then I'm predicting the value on my X data set, test data set, I'm sorry. Okay. Then I'm okay. Let's talk about this much only. So here you can see the accuracy of my classifier on training set is 77%, and accuracy on my test data set is 73%. But this accuracy is not going to help much, because if you look at the data set itself, in the first, we had around 73% of classes as no and only 26% as yes. Okay, so if I take a random guess and for everything if I say no, the accuracy will be 73%. Okay, so here if I only after applying the model, if I am getting a accuracy of 73% itself, it means it could be a random guess for everything I could have said no. So the accuracy only will not going to help here. Here we have to talk about the precision, recall and other factors to check the model accuracy. So here you can see I have drawn the confusion matrix. It means from the from the no class, my total 713 predictions are right, and from the yes class 263 are right. Okay, and the accuracy is 73%. The precision for 0 class is zero point 0.9, the recall is 0.72, that is quite good, but for class 1 the precision is only 0.949 and the recall is 0.77, so that is not good. We have lots of improvement to make in our data set because we have not done any feature selection. Maybe the smart is not doing good in the data set, so we can try another methods. Okay, and then the precision should also be a good thing to look at. So that's how you can look at our your model performance and decide which to take. So we'll talk about couple of more models. Here I am taking the logistic regression model and doing the same thing. The coding is same, only one line is different. The thing which I am calling the model I am taking. Okay, so here you can see the model accuracy is 74%. It's much better than the Gaussian naive Bayes method. So the logistic regression is doing better than that, and the precision and recall is also better if we compare with this one. So we can say the logistic regression is doing better. So you can see at the confusion matrix, this is also better than the earlier one. Let's look at the decision tree classifier. So I'm taking the decision tree method over here, decision tree algorithm over here. Here you can see the improvement. The accuracy for test is only 0.72%, that is 72%. So it has reduced. The precision for one class is also reduced. The precision for zero class is also reduced. So it means this is not performing very well. Okay, another method I'm taking the nearest neighbor method algorithm, and here you can see the accuracy went down to 70% and the precision and recall both are down for this. Okay, the last one I'm taking the that support vector machine algorithm, and here you can see the accuracy has improved to 75%. The precision and recall are, you can see, are good with respect to other models. So that's how we need to go ahead and check if my features are correct, which features to take, which features can be dropped. Then we can try all these models again, check the accuracy, check the precision, check the recall, and once you are satisfied with the performance, you can go ahead and select the model and you can deploy it in your real world. So that's how we can process with the data science model end to end. I hope the video or the session was good as per your expectation. And in coming projects, we will take these things, feature selections and other parameters in details very soon. But in our please refer my next videos or the past videos to understand the concepts of what is box plot or other details of the system. Okay, so thanks all. I will see you in next video. Have a nice day.